for tuning into this week's Stacker Chat. Stacks is smart contracts for Bitcoin, and I'm joined by Muneeb Ali, Stacks founder, with your weekly updates. So today we're going to focus on Stacks' connection to Bitcoin. So can we start on what is the two-way peg problem for Bitcoin, and how does Stacks provide a solution?
Yeah, so I think if you think about the core problem that Stacks kind of like focuses on is adding more functionality to Bitcoin. Like I think all of us love Bitcoin as a store of value, as sound money, and we are all interested in like, hey, how can we make Bitcoin more useful in different applications and so on. So people have looked at this issue for a very long time, and the general approach that I think people try to take is effectively trying to move Bitcoin to another system. Let's call it a side chain or some other layer, and then bringing it back in a as trustless manner as possible. Right. So let's call this like a two-way peg type of a solution. Right. So the idea is that can you do a transaction that locks your Bitcoin on the Bitcoin main chain and issues some sort of a Bitcoin derived asset on a side chain, and then can you bring Bitcoin back from the side chain to the main chain, meaning that logic on the side chain would trigger the unlocking of your Bitcoin on the main chain. Right? That's the theoretical idea. It's the bringing Bitcoin back part that is the technically challenging aspect. Right? So I think there has been many kind of like research papers or proposals around these things, but at a high level, I think it's safe to say that there's no trustless two-way peg system that is live today. Most of the systems that you see where people kind of like confuse these things with sidechains would be, one example would be Liquid, which is a federated network that had a trusted multi-sig wallet. And that's how people are moving Bitcoin to Liquid. LBTC gets issued there. You're kind of like trusting the federation to operate the network, and you're trusting the multi-sig wallet holders, which is Blockstream, to basically they control how the Bitcoin comes back and so on, right? Whereas the ideal of a two-way peg is that it's basically completely trustless, that you can just do a transaction. So they want the security to be similar to Lightning, right? Just like in Lightning, anyone can do a Bitcoin transaction to basically abort their Lightning channel, and so the security of their Bitcoin is kind of like in their own hands, right? So in a ideal world, the two-way peg system would be similar. That whenever the user wants to send, the user can basically bring back Bitcoin in a completely trustless manner, and that exists for Lightning. It doesn't really exist as far as the sidechains are concerned. Right? So whenever people think about adding more functionality to Bitcoin, I think they default to this fairly hard problem of like, hey, how do you have a two-way peg system that is fully trustless? And that's how you're going to add more functionality. So the idea is that once you issue some sort of a derived Bitcoin asset on a sidechain, the sidechain can be more programmable, right? So it can have fully expressive smart contracts. You can build interesting things there, and then eventually you're bringing your Bitcoin back. Right? And I think people have ignored a separate category of solutions, which is effectively that, hey, instead of kind of like locking up your BTC and unlocking a derived asset on a sidechain, how about we just try to do interesting things with native Bitcoin itself, right? So you skip the part where you're locking something and then you're trying to bring Bitcoin back, but you just focus on making the native Bitcoin transactions more interesting. And I think that's the approach that Stacks starts with. We are doing some R&D on the two-way peg side as well, and we have some solutions that are not as trustless as a fully two-way peg, but they're more practical and that are live today, right? So, but I want to separate those two things because I feel like people confuse them a lot. So let's focus on the second category that not a lot of people know about and not a lot of people kind of like pay attention to it. So in that category, let's call it like expressive Bitcoin transactions or something, where you're taking a normal Bitcoin transaction and you're making it more expressive. So in solutions like these, you have this separate layer, which is Stacks, that has smart contracts that can actually read information from Bitcoin, and these contracts can react to the Bitcoin transactions. So now a native Bitcoin transaction can actually trigger a swap, right? And these are the type of swaps that are already live through Stacks in multiple ways, right? Like people have implemented different types of swaps already. So if you look at it from an application perspective, what the user really wants to do is they just want to take their Bitcoin and they want to trade it in a trustless manner into, let's say, a stable coin, or they want to purchase an NFT with it. So technically, you don't need to like first lock up your BTC, get a derived asset on a side chain, then on the side chain do a swap, right? It's actually simpler because you're removing certain steps from the process. It's actually simpler if you just directly do the swap through a Bitcoin transaction, right? So that's the thing that actually confuses a lot of people, and I've seen a lot of people confuse this because then they go like, well, Stacks doesn't have trustless two-way pegs yet. That is true. That doesn't mean that Stacks doesn't have native Bitcoin swaps. Those are already live, right? And people are already doing really interesting things with it, because in some ways it's actually simpler, right? Because you can just directly build an application instead of worrying about doing the two-way peg. And the Bitcoin in this way never leaves the Bitcoin chain. So imagine a lending application where you're trying to lend BTC and your collateral is some sort of a stable coin. Even in the sidechain approach, the way this would work is you would first lock up your BTC, you would move it into the sidechain, then you will have some sort of a stable coin collateral in the sidechain itself, and you will try to basically lend your Bitcoin derived asset in the sidechain. Over here, again, it is simpler because the stablecoin asset is on the Stacks layer, and the Bitcoin just stays on the Bitcoin chain, right? And you can just lend it directly there. So Bitcoin transactions are always validated by Bitcoin miners. So I think that's a key difference that I've seen a lot of confusion because people default to thinking that this is a two-way peg solution. It's not a two-way peg solution. Two-way peg solutions are possible through Stacks, and just like other folks, like we are doing a bunch of R&D to make more trustless two-way pegs possible, and slightly less trustless pegs are already there, right? Some solutions are already there, but I wanted to kind of like differentiate these two categories, and it's the category 2 that I think most people don't understand and don't know enough about.
Great, thank you. Now, you just dove a little bit deeper into Stacks, and specifically, Clarity smart contracts on Stacks can read and react to movements on the Bitcoin blockchain. And can you dive a little bit deeper into what features and functions might make it even easier for developers to build for Bitcoin?
Yeah, so I think that's exactly right. That the Clarity smart contracts can read Bitcoin transactions, they can react to it, and that's what makes this expressive Bitcoin transactions possible. Because whenever you do a Bitcoin transaction, the contracts on the Stack sites can react to it. So it's a little bit like at that point your Bitcoin transaction has a lot more meaning, right? Because you could trigger a condition in a smart contract, you could purchase an asset, you could make swaps, you could do all sorts of interesting things just with native Bitcoin transactions. And I think that's a key property, right? And it's actually something that's baked into Stacks like very natively. So this is another thing that people sometimes bring up, that they say that, okay, well, reading Bitcoin state is something you could do on other L1s as well. Theoretically, yes, right? You could theoretically try to do that on Ethereum. The way it would look like is you would have some sort of a SPV proof of Bitcoin state in a smart contract. But then these are two different systems, right? Like Stacks is very tightly integrated with Bitcoin. If Bitcoin forks, Stacks forks with it, right? If you're trying to implement some sort of a SPV solution in a smart contract on Ethereum, it's going to end up looking very, very complicated. And it has no direct connection to Bitcoin, right? So if there's a Bitcoin fork, Ethereum is not going to react to a Bitcoin fork, for example. And then similarly, an SPV-based solution is always going to be inferior in terms of security and also in terms of how comprehensive it is to a full node approach. So the Stacks nodes, like they basically, the solution here is not SPV based. Like you have access to full Bitcoin nodes, and that is a more secure way of doing things. So I think that's kind of like the separation. And plus, I think from a purely engineering perspective, Stacks is a project that is focused on just this problem. Nobody else is doing that, right? Like Ethereum is not designed to be as compatible and as tightly integrated with Bitcoin as possible. They're just doing their own thing. And I think there's a huge difference from a day-to-day engineering perspective. If all of your code, all of your libraries are very, very tightly integrated with Bitcoin. And I think that's a huge advantage that developers have on a day-to-day basis if they're using the dev tools that are in the Stacks ecosystem. And those things are improving over time. Right? Like new libraries are coming out, and it's becoming easier and easier to do cross-chain things, to actually play around with swaps and so on.
Great, thank you. And what information, from the Stacks blockchain is hashed to the Bitcoin blockchain? And can you elaborate on how useful that information is and what might stop other chains from hashing historical information and sort of trying to replicate that functionality as well?
Yeah, so I think hashing information and publishing it on Bitcoin is nothing complicated, right? Like anyone can do that. So to answer this, like let's step back a little bit first. Right? Let's look at these. So almost like people should think of Stacks as like hybrid. People are building hybrid applications. Part of the application is literally on Bitcoin because you're sending Bitcoin transactions to actually interact with the application. And part of the logic an application runs on the Stack side. So there is almost like a different security assumptions for the two types of transactions. The transactions that you're just doing on Bitcoin, they're Bitcoin transactions. They're as secure as any other Bitcoin transaction. That's like the highest level of security that you can actually have. That it's processed by Bitcoin miners. Your Bitcoin remains on the Bitcoin chain, and that's it, right? That's better than side chains. It's better than kind of like anything else that anyone can come up with because it's pure Bitcoin. You don't kind of like become more secure than that. And then I think there are the transactions that are happening on the Stacks layer. Those are the ones that are getting hashed, and their hashes are automatically being recorded on Bitcoin. So what benefit does that give? I think the main benefit that it gives is that the fork histories of Stacks are basically archived in Bitcoin, meaning that you only need one copy of the Stacks data to live in the world, and anyone can reconstruct the full history of that additional data just by looking at the Bitcoin chain, which I think is solving a very important problem. And that problem is that because Bitcoin is so secure and so decentralized, you cannot have too much information at the Bitcoin chain level, right? So Stacks is acting as this almost like external storage, like external data layer, you can call it, for applications that really shouldn't be built at the Bitcoin main chain, right? These are Web3 applications. These are smart contract logic. These are NFT data. Basically anything that you can think of that should be in a blockchain, but should not be in the Bitcoin blockchain, right? So it's like an external data storage layer. And that data storage layer has a very interesting property that as long as there is a single copy of that data available in the world, anyone can come in and prove by looking at the hashes and the fork histories on Bitcoin that this is the correct version of the data. And I think that's a very, very interesting property to have because practically speaking, it's very hard to nuke all valid copies of the Stacks blockchain from the planet. Like there will be some person out there in the world or some organization that has a incentive to actually keep that data. And I think that's why Stacks mining also plays an important role, because Stacks miners are incentivized to keep a full copy of this additional data, right? And that's why actually it's important that there is a gas asset that is incentivizing those miners to keep the copy of the data and to constantly basically hash these transactions and automatically store them in Bitcoin. So that is the function that the miners are providing. So everybody else just gets that benefit for free. So if you're a developer, you don't have to worry about who is going to maintain a copy of this data, who is going to hash these things and write it to Bitcoin. That is automatically happening based on the system that's already live. And you can just focus on building your application, right? So that's a very interesting system. And even with other types of works that are currently more in the R&D stages, let's say ZK rollups or other ZK technology that can help kind of like even scale certain applications on stacks and even have direct consequences for Bitcoin smart contracts and so on. All of these solutions typically require some sort of a data layer. So even for ZK-based solutions around Bitcoin, you would end up requiring some sort of an external data layer. And Stacks is already providing that. So it's like this foundational technology that enables not just the functionality that you're seeing today, but it also enables future interesting things like ZK-based solutions that would require this data layer to be there. And Stacks basically already have that available today that people can use and people can build upon this public infrastructure to do more interesting things.
Like these videos, subscribe, and let us know what questions you have in the comments or on Twitter. And thank you.